All right, so this is a couple of the power relationship calculations that we're going to need to know to properly analyze a circuit. So what we've got here is, whoops, I'm going to draw this in. We've got an AC source with a voltmeter reading 118 volts, clamp on an ammeter on the line. It's reading 12 amps carrying out to this load, and we've hooked up a watt meter on this circuit, and the watt meter is showing 1100 watts. So if you calculate your VA, 118 times 12, it comes out to 1416. So our VA on this system is 1416. Well, our wattage is 1100. So obviously this is not in unity, right? There's some extra volt amps floating around in there for some reason. So what would they be? Well, they must be reactive volt amps, right? That's what they've got to be. So what we're going to do is we're going to determine how many of those reactive volt amps we have in this circuit. And the way we do that is simply by creating a power triangle and using some trigonometry and some Pythagorean theorem. So along our base is always our wattage. We've got 1100 watts. Along the hypotenuse, we've got our VA, which is 1416. And that means that our VARs, here, are going to be, well, there's a few, are going to be something. Well, there's a few ways to determine this. And I'm going to just kind of go through what they are right here. So the simplest way is to use Pythagorean theorem. So we can go 1416 squared minus 1100 squared equals, I'm going to take the square root of that. Or sorry, I should draw this. If we draw this over here, get rid of this square root here, and then that'll actually give us the answer that we're looking for. So we'll go 1416 squared minus 11. Whoops. So that gives us 891.66 VARs. Okay. So there's one way. Now, if we don't want to do it, there is some other ways. So we can determine what our angle theta is, because we know that the cosine of this angle is the ratio of the adjacent side over the hypotenuse, right? That's the cosine of the angle theta is going to be the adjacent side over the hypotenuse. So this is the part of that SOHCAHTOA you may have heard of, you've probably heard of by now, we're going to be using. So if we go 1100 over 1416, we get a value of 0.777. I'm just rounding that up to 0.777. Okay? we're going to come back to that number in a minute, but just for right now, we're just using it to calculate out. So if we take the inverse cosine of that, we get 39.02. So that means that angle theta is 39.0, so we're just going to round it off and call it 39 degrees. Okay? The sine of angle theta is the opposite over the hypotenuse. So if we want to use this formula, we can go to sine of 39 equals bars divided by 14/16. Sine is the opposite side over the hypotenuse, right? So you write it out like that. When you transpose that, it works out to sine 39 times 14/16 equals bars. So we go sine of 39 times 14/16 equals 891.1. Basically the same thing, right? We're out by 0.55 between you and me, not a whole lot, right? So that's the way the sine is used, and the tangent of 39 is equal to the opposite side over the adjacent side. This tangent formula is pretty common, and we use it. It can be used quite a bit, and a lot of times we underuse it. So the tangent of 39, because we're still working with that same angle theta, equals opposite, which is still bars, over the adjacent side, which is our watts. Of course, we move that around. It means the tan 39 times 1100 equals bars. So now we'll go the tangent of 39 times 1100 equals 890.8. Basically 891. So this one's would round up to 892. This one, using this formula, worked out to 891. This one would round up to 891. Really, they're all basically the same. I mean, we're within 0.5 bars is really not a significant difference, right? And if you use more decimal places on your angles and your and whatnot, it'll get a little closer. But for all intents and purposes, it's showing that those are the same. Those are the same. Okay. Now, the reason that this is it's so important to know how to use the cosine, how to use the sine, how to use the I should write this out for you. Right, that's what we did in this. So that we used the cosine here, the sine here, and then the tangent was that one there. Okay. The reason that we use those is it's rare that we get all of these values, right? You're going to run into in times where they might tell you that you have a load that's running, an 1100 watt load that's operating at a power factor of 0.777, right? Or they might call that a 78% power factor. There's different ways that they'll give you that. You can always take your power factor is the cosine of that angle theta, right? So if they tell you it's got a power factor of 0.72 or whatever, You can use the inverse cos of your power factor to get this angle, and then you can use your sine to find your missing side, or your tangent to find your missing side, depending on what you've got, right? You don't always have to use Pythagorean theorem, but you can. This is just a quick little, I just wanted to go through this quick to show you how all of these different mathematic functions related in terms of finding your power relationships.